So I've shared the worksheet, right? How many of you have completed? How many of you have submitted already? No one. Work, energy, power. I asked you to complete the second worksheet. This worksheet I asked you people to complete. How many of you did? If not completed, today will be the deadline for it. Completed. Are you guys able to see these questions? So we'll do some previous year JEE problems. Listen. So let's start with the 2019 April question. So let's try this. Do it fast and tell me. A uniform cable of mass m and length L is placed on a horizontal surface such that 1 by nth part is hanging below the edge of the surface. To lift the hanging part of the cable up to the surface, the work that needs to be done is. So we did this kind of a problem on the other day. What is the answer? A uniform cable of mass m and length L is placed on a horizontal surface such that its 1 by nth part is hanging below the edge of the surface. To lift the hanging part of the cable up to the surface, the work done should be. Guys, fast. I've already taught two kinds of two problems based on this concept. What are we supposed to do? Srivatsan, tell me.
First, draw the diagram.
See, this kind of a problem you can have in your mind. So first, what are we supposed to define?
Linear mass density.
Okay, so linear mass density is m by L. See, these kind of questions come in the exam. See, when you practice, you draw all these diagrams. But when it comes in the exam, you need to be fast. So lambda is equal to m by L. Next. You need to. So why are we writing linear mass density? To find mass of which portion?
1 by nth of the.
Yes. So what will be the mass of m by nth of the portion?
M by Ln.
It is lambda into?
N.
Lambda into n.
Lambda by 1. By N.
Lambda into L by n. Lambda into L is mass. So that's what you told m by n.
Yes, sir.
Okay. So what will be the weight? What will be the weight of the hanging part? It will be mg by n. And where will it be concentrated? So what will be the potential energy? So weight will be concentrated at which point? So you have the hanging portion. I told you on the other day. If this is L by n, the weight is concentrated exactly at which point? At a height of L by 2n from the top. Right. So what will be the potential energy? Potential energy will be weight of that part into the height through which you are supposed to lift it. So mgl by 2n square. See, now I solved. Actually, you need not solve this problem. So answer is 1 by 2 into mg by n into L divided by 2n. This is how you need to remember. So if the hanging part is 1 by nth of the portion, then 1 by n divided by 2 will be the height through which you need to lift it, because the weight will be concentrated at the center. Are you guys able to understand?
Yes, sir.
So from next time, you can directly say it is mg L by 2n square. As I told you, it can also be used like a formula to solve if there is any other problem that is given. You can score 4 marks in no time. Okay, next. Let's try this. So block of mass m kept on a platform which starts from rest with a constant acceleration of g by 2 upwards as shown in the figure. Work done by the normal reaction on the block in time t. Okay, so how to solve this? How to solve this, guys? So what comes to your mind when you see that the platform itself is moving?
Non-inertial frame of reference.
Very good. So if it is non-inertial frame of reference, what are we supposed to do? For us to apply Newton's laws, we need to
Take the weight as m into a plus d by 2.
excellent. So why did you get that a plus g by 2?
Because when it
But,
is moving up, it feels an extra force.
okay, but I taught you another concept for that. When you deal with non-inertial frames, what are we supposed to do? We need to consider some extra force, which is actually not there. The name of the force starts with P.
Pseudo force.
Yes, you need to consider a pseudo force. That is the reason why you are getting. So, since this is a non-inertial frame, ensure this is made as an inertial frame for us to apply Newton's law. It is then you can find the normal. Right. So, how will you apply the pseudo force? You need to apply the pseudo force on the block. So, what is the formula for pseudo force? Harini. Mass of the object into
Acceleration of the inertial
of
frame.
whom? Very good. Acceleration of the non-inertial frame. So mass of the block is m and acceleration should be applied in downward direction. So it is mg by 2. Now when you draw the free body diagram, there will be a normal force offered due to the platform. Mg will act downwards and mg by 2 will act downwards. See, actually, you might think, see, non-inertial frame is going to be tough, but think of this aspect. Always when there is a question based on work done, okay, what did I say? So when you need to calculate work done, what are the questions you people need to ask? So first thing is work done by which, fill in the blank, work done by which?
Force.
Yes. So first question you need to ask is work done by which force? If you know that answer, the second question you're supposed to ask is whether the work done by that force, whether the force which is doing that work, is it a constant or variable? So in this context, if you see, they have clearly mentioned work done by normal reaction. So normal reaction, if you look at the expression, right, since you have converted it to a non-inertial inertial frame of reference, now what will be the value of n? So in the vertical direction, what will be the value of n base?
M into g plus t by 2.
How much is it? That's 3 mg by 2. That's right. So if you observe this expression, m is a constant, g is a constant. So in this question, normal reaction is also a constant force. So What is the basic formula for constant work done by constant force? Work done is equal to force into displacement into cos theta, accepted. So force that is acting is normal into, if you observe the displacement of this object is in the same direction as that of normal, so into S into cos 0 degrees. So normal is 3 mj by 2. Did you guys understand this? So what is our work? We need to find the displacement. So to find the displacement of the object, what are we supposed to do?
Equations of motion.
Yes, applied. So S is equal to ut plus half at square. So the platform itself is starting. So the block is starting from rest. So u is 0. So S is equal to half into, what is the acceleration of the block, guys? They have mentioned it in the question. It is g by 2. So half into g by 2 into, they have told in time t. So half, so it is g by 4 into t square. So what are we supposed to do? Take this and substitute it here. What will be the answer? 3 mg square divided by 2 t square. Did you guys understand this? Actually, the problem is simple. What are we supposed to think? Only in terms of inertial and non-inertial frames of reference. I hope it is clear. Moving on to the next one. Siddharth, you're there?
Yes, sir.
This question you answer. So read it. The force acts on a 2 kilogram block so that its position is given as a function of x is equal to 3t square plus 5. What is the work done by the force in the first 5 seconds? See, generally we call the force as a variable when it is a function of
Time.
no. The force is a function of you do. So what is the, sorry, repeat it. Yes. So work done is equal to f dx, right? So whatever is inside the differential coefficient in the integral, then force should be a function of that value. Okay. So force acts on a 2 kilogram block so that its position is given as a function of time. What is the work done by the force in the first 5 seconds? So how do we do this? So what idea are you getting?
Sir, we can find the acceleration by differentiating the equation.
Okay, you'll find the acceleration. Then?
And then find the force and then substitute the value of t as phi and then get the value of x.
So if you substitute t as 5, my question is, will you get instantaneous time or the time? So you read the question carefully. What is the work done by the force in the first 5 seconds? If you substitute t is equal to 5 in this, the value of x you are getting is the displacement at 5 seconds. So what are we supposed to do?
Integrate
Zero.
Is we have to integrate it, but integrate what? So first let's start up. F is equal to ma. So the logic is again simple. What is the work done in the first 5 seconds? That's what we need to think. So F is equal to ma, which implies F is equal to mass of the object is 2. Into, to get the acceleration, it is d square x divided by dt square. What is the value? You guys do and tell me. let's see what you're thinking. So 2 into, so what is the d square value of d square x by dt? Is it not 6? Right? See, after this, what do you want to do? Guys, think, okay. Whether it is right or wrong, let's discuss.
Sir, okay, f is equal to 12, sir. Then you
Which is a,
find dx and then you integrate, sir.
okay, I find dx. Okay, I find dx. Okay, I get x dx in terms of dt. See, I can use the formula work done is equal to f into dx with an integral, provided force is a variable. But according to the way I see here, force itself doesn't seem to be variable. So what am I supposed to do? I will be able to calculate it. If I'm able to calculate what is the displacement that is taken place, Srivasan, you're able to understand what I'm saying.
Yes,
So
sir.
I can write W is equal to integral of f dx only when I cannot use it whenever whenever things are variable. Here the displacement is variable, but what is constant?
Force is
Force is constant according to the expression that we are getting. Am I right? So you cannot
yes.
just like that integrate. So again, we are supposed to use f into s into cos theta only. So what is our work? Instead of thinking in terms of f dx, our work is to find what is the value of x between 0 to 5 seconds. So how do we do that?
So then we substitute the value of t as 0, 1, 2, 3, 4, 5, and then add them all.
Yes, you have to do that. But if you substitute 0, 1, 2, 3 and all, you don't know what is the displacement at half second. You don't know what is the displacement at half second. So all those things also, because every second the displacement is, see, it is not a uniform displacement that is happening. What is happening? Every second, the displacement value is different. Means between 0 to 1 second, it would have been different. Between 1 to 2 seconds, it will be different. So I cannot add them. So what are we supposed to do? Okay. I'll tell you. Let's think of all the possibilities. Okay. Guys, are you able to understand what are all the mistakes that will happen? I'm more concerned about that. Why you are not supposed to do. So I hope you understood the logic. So one, we cannot use integral of f dx because force is not a variable, but displacement is changing. So what you can do is, if I need to use integral of f dx, okay, I'm repeating, if I need to use the integral of f dx, then I need to know what is the position of the object between 0 to 5 seconds. So what is the position of the object exactly at 0 seconds?
5.
It would have been 5. So they didn't give the unit, right? So since it is given in joule, I'm assuming it will mean meter. Okay. 3t square plus 5 meter is what I'm assuming. At 5 seconds, what is the displacement?
80 meter.
80 meter. So what I can do is, here I'm writing work done is equal to f into integral of dx. Can I write it like this? So this is a slightly different question. So I'm not writing integral of f dx, I'm writing it as force into the net displacement. Net displacement in this case, Harini, like how you told, I cannot use sigma because I don't have discrete values in my hand. Rather, I have only continuous value. Wherever function comes, we need to think of integration. Calculus comes into picture. Are you able to understand? You guys know when to use sigma and when to use integral, right? Sigma can be used when you have discrete values. Integral is used when you have continuous value. When the values are continuously changing, then you need to use integral. So integral of dx between which points? X equals 0 to x equal to 5. So f into so integral of dx is x. What is the displacement of object at 5 seconds? It is How much did you say? 3 into 25, 75 plus 5, it is 80. At x is equal to 0, it is 5. Into x between 5 to 80. So f into 75. So f is 12. 12 into 75, whatever is the answer. Final. So 12 into 70 is 840. 12 into 60. So 900 should be the answer. Guys, did you understand? Okay. Now comes the important point. So 900 joule is the answer. I hope you would have understood this. But is there an alternate way I can solve this problem where I don't want to undergo all these processes? Too much of mathematical processes involved. Right. So in this question, I'm able to understand one thing. The force is not a function of displacement. Rather, the displacement is a function of time. It is an indirect connection. Right. So and I'm asked to calculate work done. I have only two formulas for work done: F into S into cos theta or F into integral of dx. Both of which I cannot use it directly here. I need to do some mathematical manipulations. But there is one theorem which will save us every time. I told you already.
Work energy theorem.
If you think of work energy, wherever you need to calculate work done, yes, you need to think of work energy theorem. Let's see how the problem will get simplified if you use that. Okay, I want you all to start thinking in terms of work energy theorem, not only in this chapter, even in kinematics, you can do that. Please start using that, okay? So work done is equal to change in kinetic energy. Right, work done is what we need to calculate. Half into change in kinetic energy is half mv square minus mu square. So half into m will come out v square minus u square. Is it easy for us to calculate v and u? So x is equal to 3t square plus 5. So dx by dt is 60. So what is the velocity at 0? Half into mass is 2. So x is equal to 3t square plus 5. So velocity will be 60. So what is the velocity at 0? Okay. I asked a simple question. V is equal to 60. That is, if you differentiate x
0.
with respect, it is 0. What is the velocity at 5 seconds? 30. So 30 square minus 0 square. 2 and 2 are gone. 900. Same answer, but in less number of steps. Got it? So wherever the object has the capability of changing its velocity, it's easy for us to calculate the work done using work energy theorem. Again, this problem is also simple. It depends on how you think. See, it took so much of time because we discussed, but when you solve it in the exam, you can do it fast. Trust me. That comes with practice. So shall I move on? Yes, Siddharth, you answered this one. The last one you couldn't know. So try this one. When a rubber band is stretched by a distance x, it exerts a restoring force of magnitude F is equal to ax plus bx square. So looking at this, what comes to our mind? Forces. Variable. It's a variable force. So the work done in stretching the unstretched rubber by L. So what do they mean by unstretched rubber? Means you can take the extension of an unstretched rubber to be 0. So since you are saying it's a variable force, what formula are you going to use? Siddharth? Integral of f dx. Integral of f dx. By them saying unstretched rubber, what am I supposed to take the lower limit as? 0. That's right. So 0 to L. So the meaning of this is, if you want to visualize it, if this is the rubber on a microscope, on an extended version, sorry, on a zoomed version, okay. If I apply a force, then this is the reference line. From this reference line, what they are saying is it has got extended by a distance L. So if you take the reference line to be 0, the bottom will be L. That is why it is 0 to L. Now integrate this and tell me fast. You can directly say the answer. When you integrate x, you get x. Option
C.
Yes. Right, you need not sit and do. Integral of x is x square by 2, integral of x square is x cube by 3. In that position, whenever the denominator is 0, you're just going to substitute the upper limit. So when you substitute upper limit, al square by 2 plus bl cube by 3. Right? Now, so this advanced and all we'll do it later. So this is a type of problem. These are the types of problems which are based on work done and power. Okay. Now let's do some problems which are based on friction. Okay. So there is a point particle of mass m which moves along a rough horizontal track PQR as shown in the figure. The coefficient of friction between the particle and the rough track equals mu. The particle is released from rest. From the point P, it comes to rest at point R. The energy is lost by the ball over the parts PQ and QR of the track are equal to each other, and no energy is lost when the particle changes direction from PQ to QR. The value of coefficient of friction, mu, and the distance x that is equal to QR are respectively close to. So how do we approach? So read the question, you take time. You guys tell me what comes to your mind. How to do, guys? So read the question. Think of the hints they are given. So what are the hint that you are able to see? So what are the first hint that they have given?
So H.
Okay. No, H is a data. H is not a hint. So the hint is in a statement. Read it, no? See, I'll just tell you the way I analyze this question, okay? I look at this question like this. There is a point particle, okay, point particle is having mass m and is moving along a rough track. My question is, what is the rough track you're trying to speak about? So P to Q is rough and Q to R is also rough, okay? So the coefficient of friction between the particle and the rough track equals mu. Means from P to R, the whole track is having a coefficient of friction mu. So till that it is a data. The particle is released from rest. So when they say rest, immediately I think of U is equal to 0. Means its kinetic energy is 0. That's what runs in my mind. Okay, when this problem is asked in friction question, right? That is how I think. So U is equal to 0. Kinetic energy is 0. From the point P, and it comes to rest at point R. Here also, the velocity is becoming 0. So one thing we need to understand, the particle is released from rest and the particle is coming back to rest during its course of motion. So what should have happened? It should have lost energy. And it is losing energy due to whom? Energy can be lost only due to a resistive force. It is because of friction. Okay. Okay. So now I came to a conclusion. So that's what I understood till this point, till R. Okay. Here comes the hint. The energies lost by the ball over the parts PQ and QR of the track are equal to each other. So what are they trying to say by this statement? They need not give this, right? They're given this. So that is the hint. So this is hint number 1. Let's see if there is any other hint. And no energy is lost when the particle changes direction from PQ to QR. And no energy is lost when the particle changes its direction from PQ to QR. Okay. So what are they asking? The values of the coefficient of friction, mu, and the distance QR are respectively close to. So now I have a question. What do they mean by this term? What am I supposed to do? What mathematical equation can I frame from this? The energy is lost by the ball over the parts PQ and QR of the track are equal. So what do I do with it? Why have they given it? Okay. So let's think another point. If suppose I need to use an energy theorem, because they're speaking about energy, clearly I know that I need to use some energy theorem. Now I need to raise two questions. I know two energy theorems. What are the? Energy conservation and work energy theorem. But which am I allowed to apply it here? Which am I allowed to apply here?
Work energy theorem.
Work energy theorem, because energy conservation is applicable. Reason being?
Because non-conservative force is acting.
Non-conservative force, and logically thinking energy is lost. Conserved means what? Conserved means something is preserved, right? So energy conservation is lost, and what logic you told is also right. Non-resistive force, sorry, resistive force is acting. Now I need to apply work energy theorem. So work done is equal to change in kinetic energy. I know this. Okay. Second question. When I am applying work energy theorem, do I need to give sign convention to work done?
Yes, sir.
Yes, work done can be positive, negative, or zero. Whereas energy conservation theorem, there is no sign convention because energy is always positive. So work done. Now comes the question. 1 minute. Hope this class is recorded here. So work done is equal to change in kinetic energy. So I'm saying this. What did they say? Energy lost by the ball over the parts PQ and QR. So what is the work done in the part PQ? This is equal to. Okay. Now tell me what work done is equal to kinetic energy. So who's doing the work? The loss in what is equal to the gain in what? Now, what are all the forces that are acting on the ball? Sorry, okay. Can you tell me what are all the forces acting on the ball?
A frictional force, gravitational force.
So it's weight. So if I call this distance as d1 and I call this as x already. So now comes the question. Since you're saying work done has sign convention, now I'm going to take it like this. Anything downward, I'm going to call it as positive. My wish, right? And anything in this direction is taken as positive. Now tell me. So work done by, so what are all the force? Work done by gravitational force plus work done by friction in PQ plus work done by friction in the distance QR. Correct? So what is the work done by the gravitational force according to the sign convention that I have considered? Sorry, no? So mg is acting downwards and displacement is taking place in which direction? So mg is acting downwards. In the direction of mg, what is the displacement that you're able to see? It is h. That's what we technically call it as potential energy. So mg into h. Did you guys understand why I wrote plus h? Because h is also in the downward direction. Accepted? So what is the work done by friction in the path PQ, guys? So on an inclined plane, what is the value of the frictional force that acts? Mu n. What is the value of n in the case of inclined plane, where angle of inclination is theta with horizontal?
mg cos theta.
Yes. So what will be the frictional force? It will be mu mg cos. What is the value of theta? 30 into displacement is how much? According to my diagram, tell me.
d1.
D1 into what is the angle between the frictional force and D1? I've given sign convention. The
180.
direct is 180 degrees. So work done by friction will be negative. That goes without mentioning. So minus mu mg cos theta cos 30 into D1. In the case of QR, tell me, it's even more simple. Minus. So on a horizontal
Mu
surface,
mg.
what? Yes, on a horizontal surface, it is mu mg into what is the displacement it has cost?
X.
That's right. So you have written the sum of work done by all the forces. I hope you are able to understand how to think in terms of work energy, right? So left hand side is equal for everyone. Sorry, left hand side. Did you guys understand? Everyone?
Yes, sir.
Okay. Is equal to change in kinetic energy. Change in kinetic energy between which 2 points? Between P and R. So you are concerned only about the initial and the final position. So if you observe in this question, the initial and the final position, what is the velocity?
0.
So what should I write? Change in kinetic energy is 0. Right. So mgh will be equal to mu mg cos 30 into d1 plus mu mg into x. Did you guys understand what I wrote? So I got this expression from where? From work energy theorem. See, look at the way I'm analyzing the same thing in a different way. I am saying, what is this whole thing? This is the total work done by friction. This is the decrease in potential energy. There's another way. So in this question, what is happening is the decrease in potential energy is causing the work to be done by the friction. There's another way to analyze, but I will suggest you to always use work energy theorem to solve the problem. Right? So this is from work energy theorem. But what did they ask? What is that you're able to understand from the hint? The energies lost by the ball over the parts PQ and QR of the track are equal. So what is the energy lost in the part PQX? So energy is lost in the part PQ due to whom? We need to raise that question. Who's making the ball lose energy? Is equal to loss in energy in QR. So loss will always take place due to the resistive force. So loss of energy, wherever you see energy, you need to calculate work done. Work done by which force is decreasing the energy? Obviously,
Frictional force.
frictional force. So indirectly what they are saying is mu mg cos 30 degrees into PQ, that is D1, is equal to mu mg into x. Okay. Now it's easy for you to solve. Now comes the mathematical part. What is the relation between D1 and H that is given? H1 by D is
Sin 30.
So H1 is H by D1. Sorry guys. H divided by D1 is sin 30. So D1 is equal to H by sin 30. So D1 will be how much? H is 2, sin 30 is half. So 2 will go up. D1 will be 4 meter. So if you substitute 4 meter here, mu mg and mu mg will go. So 4 times cos 30 is equal to x. So 4 into what is the value of cos 30 guys? Root 3 by 2. This and this will get cancelled 2 times. So 2 into 1.7, it is 3 point something. So 3.5, there are two options. So we need to find the coefficient of friction. It's approximately 3.5. All right. So take this and substitute it here. You can get the value of mu. Mg gets cancelled. So what will you get? H is equal to mu into cos 30, that is root 3 by 2, into d1 is 4 plus x is 3.5. So this will cancel 2 times. So this is already 2. Just calculate and tell me what is the answer.
So 0.29.
0.29. That's right. So 0.29, 3. That's the answer. Clear? So this is a very good problem because, see, this kind of a question can be expected. Like how I'll tell you the different kinds of questions that they are going to frame. So what they will say is, I'm just telling you different types of questions. Let's say there is a point P which is at a height h1. Okay, there is a ball, a particle which is released from rest. Okay, now they will ask, they'll put friction here in between, and they will say these two are smooth surface. They can use any permutation combination. It's up to them. Okay, let's say these two inclined planes are smooth. Now they will ask, when the ball is released from here, then what height will the ball be able to reach on the second inclined plane after traveling a distance of, let's say, x, something like this? Are you guys able to understand? So when this comes, how will you think? So it's always advisable for us to think in terms of work energy theorem, because here also we cannot apply energy conservation because there is some energy lost here because of the friction. So you're able to understand. I just gave random question because I have not given the sufficient data, but I'm just telling you these kind of questions can be framed. And I've seen many times these kind of questions being repeated. Okay, sometimes what they will do is they will combine this chapter with something else. Like for example, if they want to find the non-resistive force that is acting, they can combine it with viscosity, which is in fluid mechanics. They can do it. Or they can combine the same thing with electrostatics without a resistive force. Anything they can do. Okay. But most of the problems in physics, almost 90% of the problems in physics can be solved using work energy theorem itself. If you guys master this, nothing like that. You can start thinking in terms of work energy theorem for most of the problems. Okay. So this is all about the 2016 question. Now we will do another problem. Let's see. So let's do the integer type question. That is the fifth one. Let's try this. Now listen. There is a block of mass 0.18 kilogram, which is attached to a spring of force constant. It is spring constant, 2 Newton per meter. The coefficient of friction between the block and the floor is 0.1. Initially, the block is at rest and the spring is unstretched. An impulse is given to the block as shown in the figure. Okay, next. The block slides a distance of 0.06 meter and comes to rest for the first time. The initial velocity of the block in meter per second is given as v is equal to n by 10. What should be the value of n? That n should be an integer value. I'm giving you 3 minutes time. 7:50 is the time. 3 minutes, you people try and come up with an idea at least. Rahul, you're there?
Yes, sir.
Yeah. So how do we do this? What idea are you getting? Whether right or wrong, just say. Whatever idea you're getting, you say. Then I will know how you're thinking. So you understood the question?
Yes, sir.
Yeah.
Sir,
Yeah.
from the given data, we can find the work done by friction
Okay.
and then potential energy of the spring. That is
See. Yeah.
K.
1 minute. 1 minute. 1 minute. See, this when you're applying work energy theorem, no, don't bring in the word energy. Left hand side should not have energy. Okay. So how you're thinking is actually right. Can you repeat it again? You're up. So let's say you're applying work energy theorem. I hope you're applying this only because you cannot apply energy conservation because there is friction. So when you want to apply work energy theorem, Rahul, repeat it. What will you do? You'll calculate
Initial kinetic energy, then potential energy.
we'll finish the left hand side first. Work done by friction plus. See, I'm able to understand one thing. When I say work energy theorem, your mind is still thinking in terms of potential energy. Don't bring in energy. Okay, you need to think of only work done. Why I'm specifying on the word work done is because if you start thinking in terms of energy, you will not concentrate on sign, then your answer will completely change. Okay, when I say work done by friction, I will take sign into consideration. Plus, instead of saying potential energy of the spring, I will say work done on the spring. Okay, work done by friction plus, work done by the spring plus work done by the spring is what is going to change the kinetic energy of that particular block. Am I clear?
Yes, sir.
Now tell me, work done by friction, how are you going to take? Whenever you need work done, right, you need proper sign convention. So which direction you want to take as positive and which direction as negative? Right or left? You want to take the right as positive or negative?
Right as positive.
So you want to take right as positive. So when you take right as positive, what is the direction in which the frictional force is acting in this scenario? Is it acting to the left or right? friction is going to oppose only, same thing. So it is going to be mu mg. So mu mg, mu is a constant, m is a constant, g is a constant. So what is the work done by friction? Tell me. Mu mg into what is the displacement cost? What is the displacement through which this friction is acting? Let's say the spring has got compressed by a distance of x. It is the same distance x through which the block also has traveled. It is the same distance x through which the friction is also acting. Mg into, can I write it as x? Am I right?
Yes, sir.
Correct. There is a mistake.
A
Sir,
negative sign.
Yes, because I missed cos 180 plus work done by spring. What is the work done by spring? So remember
Half
spring.
kx square.
So see, this is the reason I was stressing on the point. Listen to it carefully, okay? So kx is to the left hand side and x is to the right hand side, right? So when you want to compress the spring, you need to apply a force which is slightly greater than kx, which is almost equal to kx. So if you calculate, now understand this point, okay? There is a very important point I'm stressing on. Concentrate. So this is the external force. This is the spring force. So if I put a question like this, what is the work done by the external force? Then the answer will be half kx square. Whereas when I ask you what is the work done by the spring, what should it be?
Minus half k.
Yes. If you miss that minus, your answer will completely change. Minus half kx square. That's why I told work done by the spring. Because spring is trying to oppose. That is the reason why the block is actually coming to rest. So that is the work done by spring, not the external force. Is equal to, what is the change in kinetic energy? Finally it is 0 because the block is coming to rest, minus initially it is half m into, they've given it as v, so v square. Did you guys understand how I framed this equation? So minus mu mgx minus half kx square is equal to minus half mv square. So minus is gone. So mu mg into x plus half kx square is equal to half mv square. Mu is how much? 0.1 now. How much is it? 0.1. M is 0.18. G, let's take it as 10. So 0.18 into 10, 18 into x plus half into k is how much? 2 into x square is equal to half into mass of the, oh, they have given x also 0.06, that is 6 by 100 is equal to half into mass of the block is 0.18 into v square. Okay, now see. So 0.1 into 18 into 6 divided by 100 plus 2 and 2 will get cancelled. 36 divided by 100 square is equal to 0.9 into v square. Can you guys solve this fast and tell me? So what you can do is, you can make this as 600 square. So 0.18 into 1 is 1.8. 1.8 into 600 divided by 100 square plus 36 divided by 100 square is equal to 0.9 into v square. So 6 into 1.8 is how much? 108. So 18.6 is 108. So 10.8 into 100 divided by 100 square plus 36 divided by 100 square is equal to 0.9 into v square. So it will be 1080. 1080 plus 36 divided by 100 square is equal to 0.9 V square. So how much is the answer, guys? 6, 1. So this part you calculate. Okay, take this as homework. You can do it. Tell me what is the value of P later. We'll do another problem. Listen, let's do this 5-mark problem because it has horizontal and vertical motion combined. Sometimes if your luck is good, you can get the same question also. It will get repeated. Try this, guys. So two blocks A and B are connected to each other by a string and a spring. So you have a string and a spring. The string passes over the frictionless pulley as shown in the figure. Block B slides over the horizontal top surface of a stationary block C. So this block is stationary. And the block A slides along the vertical side of C, both with same uniform speed. The coefficient of friction between the surface and the block is 0.2. Force constant of the spring is 1960 Newton per meter. So whenever you see this 196.98 and all, no, G value should be taken as 9.8. 1960 Newton per meter. If mass of block A is 2 kilogram, calculate the mass of block B and the energy stored in the spring. It's a good question. So in this question, what is a hint? I'll give you 1 minute time. You guys think and tell me what is the hint. Did anyone find it out?
Sir,
Hmm?
both the blocks are moving with uniform speed, same speed.
So they are moving with same uniform speed. No, it's not about same speed. They are moving with same uniform speed. Indirectly, what do you mean by uniform speed?
Acceleration.
Yes, acceleration
Acceleration.
is zero. So when acceleration is zero, what is it called in terms of physics? We call it as mechanical equilibrium. So when the object, so they're indirectly trying to tell you that the whole system is in equilibrium, means all the forces are balanced. If you understand that only, you can proceed with the remaining problem. Right? All the forces acting on the system, on the blocks especially, because the blocks are the subject of study. All the forces acting on the block are balanced. Right? Now comes the question. Now, what are we supposed to do? Calculate the mass of the block B and the energy stored in the spring. So it is a combination of, so first thing, it is a combination of string and spring. So it's a combination of inelastic medium and an elastic medium. Secondly, friction is there. And lastly, you need to calculate the energy stored in the spring. Right. how do we proceed? What comes to our mind? Since the concept of string is coming to picture, since we have no idea about the forces that are acting on the system and we are asked to calculate the energy, we need to start our problem with a free body diagram. So let's start with B. And here the advantage is block C is not moving. Had it been moving, then again we need to bring in, depending on how it is moving, we need to bring in pseudo force and all those things, right? So there will be a tension force acting in the rightward direction. What are all the other forces that are acting on B?
Frictional force in the opposite direction.
Hmm? They have given no the
Sir, the
coefficient of, yes,
frictional force in the opposite
friction
direction.
force, it will act in the opposite direction. What will be the value of it? Mu into mass of B into G. Is there any other force that is acting in horizontal? I'm not concerned about vertical. I know vertically it is balanced. N is equal to mb into G. Now, what about the spring? So, if I draw a free body diagram of the spring is indirectly connected to a string. This block is trying to pull it downwards. Then what will be the restoring force that is going to come in the spring? It is Kx. So, can I say that this T is equal to Kx? I'm talking only about the spring. Right? So actually what will happen is the tension will act in the downward direction. Okay, next. If you take block A, on block A, what are all the forces acting? MA into G is acting in this direction and K into X is going to act in the above direction, where X is the displacement through which the spring has got extended. Okay, is that all?
Sir, the friction on the other side between
Yes.
block A and C.
It should be in the upward direction. That is mu MA into G. So according to the way they have given, it is between the two blocks A and B. So the coefficient of friction between the surfaces of the blocks, it is not block. Surfaces of the blocks is 0.2. So mu mg MA into G. Now tell me, how do we proceed? So what are all the equations you are getting? T is equal to mu mb into G. This is equal to what? That's it, right? So this is equal to kx because T is equal to kx. I told you. This is for equilibrium of which block? B.
B.
What about equilibrium of A? Kx plus mu MA into G is balanced by MA into G. Actually, one minute. I made a mistake. It is not mu MA into G. It is actually this normal force. Right. So I think there is a mistake in the question because they have given no information related to the force that is being exerted this side. You will be able to solve this problem only if you assume this surface to be smooth. I think there is a mistake, but they have given coefficient of friction between the surface of the blocks. It would have not been a question in the exam. It's a printing mistake in this book. The coefficient of friction between the surface of. So what we will do is we will not take this into consideration. Then we can solve the problem. no information related to normal, you cannot find it out. Okay, you will get stuck. So can I write kx is equal to ma into g? So from this, you can get the value of x. X will be equal to mass of A into g divided by k. So what is the extension that is taking place, guys? Mass of A is how much? Have they given it? Mass of A is 2. So 2 into 9.8 divided by 1960. 19.6 divided by 1960. It will be 1 divided by 100. So x will be 1 divided by 100 of a meter, that is 0.01 meter. That is the extension that is going to take place in the block. Right. Now what else are they asking? They are asking the mass of second block. So we know that mu mb into g is equal to kx. So mu is how much? 0.1 or 2? 0.2 into mass of block B is how much? That's what we need to find. Into G is 9.8 is equal to 1960 into 0.0. So 9.8 into this will be 200. So answer should be 2. So MB into 0.2 is equal to, so MB will be equal to 10 kilograms. So the mass of the second block is 10 kilograms. There is no option, right? Oh, it's a descriptive question. Okay. So mass of block B is 10 kilogram. Tell me, guys, is there any doubt till this step?
No, sir.
So they are asking what is the energy stored in the spring? That is half kx square. So you know half k value is 1960. You know the extension x, substitute it, you will get the answer. Okay. Okay. So before I do the next question, tell me one thing. Do you guys remember the concept of specific heat capacity, latent heat and all? Do you guys remember that? If not, we can skip that. We will do it at later time. Since no response, I assume that you're not confident. Okay. Now we'll go to the next question. That is problems based on circular motion. Slightly tougher one. Let's do this. Let's do some miscellaneous problems. Tell me how to do this. A particle moves in one dimension from rest under the influence of a force that varies with the distance traveled by the particle as shown in the figure. The kinetic energy of the particle after it has traveled 3 meters is. How to do? A particle moves in one dimension from rest under the influence of force that varies with distance. So when they say force varies with distance, it is variable, traveled by particle. The kinetic energy of the particle after it has traveled a distance of 3 meters. So whenever they give you a graph between force and displacement, you can calculate, see for any graph, you can calculate either slope or area. So slope is y divided by x. So y is force divided by x. So f by x, there is no specific term except spring constant, but that comes only in the context of spring. So here, if you calculate f into x, you will be able to get the area. Area is work done. So what are they asking? The kinetic energy of the particle after it has traveled the distance of 3 meters. Indirectly, work done is equal to change in kinetic energy, and the object has started from rest. So what is the work done? This area plus this area. So how to calculate the area, guys? So area of the rectangle 4 plus area of the trapezium half into base into sum of the parallel sides, that is 2 plus 3, is equal to change in kinetic energy. Here it is going to be kinetic energy, final kinetic energy, because initial is 0. So 4 plus half into 5 is equal to kinetic energy final. So 5 by 2 plus 4, 2.5, 6.5 is the answer. I hope it is clear. So I want you guys to try the next one. You tell me. Aditi, you're there?
Yes, sir.
Yeah. You want to try this? Try. So what are they saying? A particle which is experiencing a force is given by F is equal to 3I cap minus 12 J cap. Is it a constant force or a variable force?
Constant.
Aditi?
Constant, sir.
Constant. So undergoes a displacement of D is equal to 4I cap. So displacement is a constant one, or so here the displacement is a function of nothing. So if the particle had a kinetic energy of 3 joule at the beginning of the displacement, what is the kinetic energy at the end of the displacement? Again, force is there, displacement is there, and kinetic energy. What can you think of? Aditi?
Work energy theorem, sir.
Yes, tell me how to do work. So work done is equal to change in kinetic energy. So what is the work done in the case of constant force? F vector,
Into x vector.
sorry,
Displacement. Displacement vector.
F vector dot D vector. It's a dot product because cos theta is equal to change in kinetic energy is final kinetic energy minus initial kinetic energy. What is F vector dot D vector in this case? When you do the dot product between both, 3I cap minus 12J cap dot 4I cap. How much is it? It's 12. So 3I cap dot 4I cap is 12 minus 12J cap dot 4I cap is 0 because J dot I is 0 is equal to change in kinetic energy. Final kinetic energy minus initial is how much have they given? 3. So what is the answer?
15 joule.
15 is the answer. Okay, that's right. Okay. Sanjana, you're there? Harish?
Sir?
Yeah. Now you answer this question. Try this. Okay. I'm not concerned about right or wrong. I want you to answer.
Okay, sir.
Just a minute. My screen got stuck. Just a minute. So there is an object of mass 10 power minus 2 kilogram moving in a medium which experiences a frictional force of F is equal to kV square or minus kV square. Its initial speed is V naught, that is 10 meters per second. If after 10 seconds, its energy is 1 by 8 times mv naught square, then the value of k will be. So what do you get in your mind? So here they're trying to speak about force and energy is given as a function of velocity. So what can we think of again? What comes to your mind? A force, displacement, and velocity comes into picture. So what can we think of?
Work energy theorem, sir.
you can again think of work energy theorem. But here we will not be, unfortunately, we cannot apply work energy theorem directly because the force is not a function of displacement here. It's a function of velocity. So what are we supposed to do? We need to think about it, right? So if you observe, its initial speed is after 10 seconds. So after 10 seconds, its energy is 1/8 mv naught square. So can I say that this is going to be the kinetic energy of the particle exactly after 10 seconds? Then they're asking what will be the value of K. So to find the value of final kinetic energy, what are we supposed to do? Let's see. Okay. So if a mass is given, so how can I write F in terms of mass? F is equal to m into A. But here, instead of writing A directly, I would prefer to write it as dV by dt, right? So dV by dt is equal to how much, guys? So if I compare both, m into dV by dt is equal to minus kV square. dV by dt, how much is it, Harish? Just rearrange the equation, no? It's what will happen, m will go to the other side. So it will be k by m into v square. That is acceleration. Now what have you done? You have written acceleration itself as a function of velocity. So you're going to use variables and separables method. So when you use variable separables, we can write dV by v square is equal to k by m into dt. Accepted, guys? Just a minute, there is a minus I missed. Because when you're integrating, minus is an important term, right? So what can we do? We have separated the variables. Did you understand what I did till now?
Yes,
Harish, you're there?
Yes, sir.
So how I need to integrate it from where to where? From the time 0 to time t. The t is 10 seconds.
10 seconds.
Okay, that will substitute it later. Initial velocity at t is equal to 0. What is the initial velocity corresponding? Here it is 10. And what is that we need? They told its final kinetic energy is half m v naught square. Let's call the final velocity as vf. Did you understand what I did? Now tell me. T I will directly substitute as 10 seconds. So integral of 1 by v square. What is it, guys?
Minus 1 by v.
Minus 1 by v. So in minus 1 by v, if you substitute vf minus v10, what are you going to get? So minus 1 by v from 10 to vf is equal to minus k by m into 10. Correct? So minus and minus are gone. So v 1 by vf minus 1 by 10 is equal to, what is the value of k, guys? K is what you need to find. K divided by, what is the value of m is given? So k by m is 10 power minus 2 into this is 10. So you will get 1000 k. Correct? So from this, find the value of vf. I'm repeating it. Here, if you observe, vf is dependent on k. So find the value of vf. Final kinetic energy will be half m vf square. In that vf square, you will have k equated to 1 by 8 m v naught square. M and m will get cancelled. So it will go 4. So vf square is equal to v naught square by 4. Equate both, you will get the value of v. Okay. V naught is how much? 10. 100. Vf square is equal to 25. Indirect. So vf square is 25 means vf is 5. So vf is 5 means 1 by 5 minus 1 by 10 is equal to 1000 k. So 1 by 5 minus 1 by 10 is how much? 1 by 10 is equal to 1000 k. So k will be 1 divided by 1000. 1 divided by 10,000, that is 10 power minus 4. Sorry, I had to cramp and do it. Did you guys understand? There's
Yes,
a
sir.
problem. Okay, so you should know how to handle it mathematically also. Try these kind of problems, and it's a 2017 question. You can expect these kind of questions. Got it? So with this, we will stop for today. The worksheet, I'm expecting you to complete it by today and upload it in the app. And upload it by today. I'll be checking it. Okay. So I want you to practice this chapter a lot, because then you will understand next chapter and all. It is next chapter is very tough. So practice. Just wait for a minute.